Welcome to Driftless.net, where we explore the history, stories, geology, geography, people, and communities of the Driftless region. Welcome to the very first episode of Driftless.net. Today we are starting at the beginning. Just what and where is the Driftless? Like most things about the Driftless, there should be a simple answer, but it gets a little complicated. To begin with, the answer is clear to a geologist. The Driftless is the area that was not touched by the massive ice sheets that covered most of upper North America. There's a clear line that separates the Driftless from the areas that were buried under up to a mile of ice. This was recognized by geologists in the 1850s, before they fully understood just how massive ice sheets worked. This is technically correct, which is a very good kind of correct. In this usage, drift means materials carried by a glacier or ice sheet. From boulders to fine silt, the ice and meltwater transport this drift from its original location and drop it wherever the ice melts or the water carries it. Originally, it was proposed that glaciers carried the drift while floating as icebergs, dropping it as they melted. That theory itself melted and was dropped, but the term was retained. The areas east of the Driftless were covered during the Wisconsin glaciation of 10 to 60,000 years ago. To the south, there was the Illinoisan glaciation of 130 to 300,000 years ago. To the north and west of Wisconsin, in Minnesota and Iowa, there was the pre-Illinoisan glaciation from 1/2 million to 2.5 million years ago. Just as the Driftless was shaped by the absence of glaciers, the rest of the state was shaped by their presence. In this map, the red areas show where the glaciers dropped their loads in what are called moraines. The glaciated areas have moraines, drumlins, eskers, outwash plains, and more exotic formations, all resulting from the ice sheets. Instead of that, the karst geology of the Driftless has been shaped by hundreds of thousands of years of erosion. The result is steep valleys, no natural lakes, and lots of springs. Why did these massive ice sheets bypass the region when they went as far south as central Illinois? The limestone bedrock may have drained away the water lubricating their underside. Despite the cold, the pressure of the ice melts its bottom, making it slippery like a wet floor. Also, the bottom of Lake Superior is lower than Death Valley, about 1,300 feet below the surrounding terrain. This probably also helped divert the ice sheets. Defining the Driftless gets complicated because that clear line that geologists see isn't really visible to the rest of us. There's a larger area with Driftless-style geography. It has the same bluffs, coulees, and springs that the Driftless has. This relief map shows just how similar those areas are to the Driftless. A geologist can definitely tell the difference, but to the untrained eye, the borders can be difficult to see from a car or even an airplane. This has been labeled the Paleozoic Plateau. It extends into Iowa, Minnesota, and the part of Wisconsin north of the Driftless and south of the moraines. This was glaciated at some point, but the drift there has mainly eroded and only traces remained. The resulting landscape looks and feels much like the Driftless because it is the result of the same processes and underlying geology. There is also an area that wasn't glaciated recently, but doesn't have the typical Driftless geology. It extends north of the Driftless into land that doesn't have the bluffs and coulees of the Driftless. It also includes Glacial Lake, Wisconsin, which also has a very different geology than the Driftless. It was covered by an outwash lake rather than the actual ice sheet. It can be included as part of the area that wasn't glaciated, but is covered with a thick layer of sand that washed out from the ice sheet. The result is the flat sand counties made famous by Aldo Leopold. I plan to cover some of this in more detail in later videos. Check out Driftless.net for links to all the maps cited and more information. Thank you for watching.